NASA plans to search for life on Jupiter's moon. NASA is planning to launch a mission in the 2020s to Europa, one of Jupiter's moons. One of its high priorities is determining if the moon's surface is habitable and identifying locations where future missions may land a spacecraft. In addition, NASA is on the search for life beneath the moon's thick, icy surface. In an interview with The Guardian, NASA's chief scientist Dr. Ellen Stofan said, "We know there is an ocean under that icy crust. There are plumes of water coming out of the cracks in the South Polar region. There's orange gunk all over the surface. What the heck is that stuff?" The spacecraft sent to Europa may either orbit or perform multiple flybys of the moon, possibly flying through those plumes of water in the southern region. That would let us collect samples of Europa's inner layers without the risk and high cost of landing the spacecraft. But any mission must protect the spacecraft and instruments from the high radiation environment. NASA also wants to ensure that we don't contaminate Europa with organisms carried from Earth. Exomoons may be detected through radio emissions. Until now, scientists have been technologically limited in their search for life outside our solar system to exoplanets, but physicists from the University of Texas believe they've discovered a way to detect exomoons through radio emissions. This may greatly expand the number of habitable bodies on which we may find alien life. Using their knowledge of radio emissions caused by the interaction between Jupiter's magnetic field and the planet's moon Io, these scientists have extrapolated formulas to search for radio emissions from exomoons. They also believe that Alfvén waves may help us spot exomoons in a similar way. In our solar system, moons such as Europa and Saturn's Enceladus have the potential to support life based on their distance from the Sun, their atmosphere, and the possible existence of water. But as our radio telescopes get more powerful and more advanced, scientists hope to conclusively study more distant bodies. Currently, 2 exoplanets with possible exomoons are the main candidates for hosting life, Gliese 876b. Both are gas giants, but many are in the habitable zones of their stars. Any exomoons orbiting these planets may have the potential to support life. Mars may have supported life before, and may again. Mars is currently too cold to house liquid water and support life. But NASA's Opportunity rover, an all-terrain vehicle that collects and analyzes rocks on Mars, has shown that about 4 billion years ago, the planet had fresh water and mud that could have supported life. Another past source of water and possible life sits on the slopes of Mars's third tallest volcano, Arsha Mons. Around 210 million years ago, this volcano erupted beneath a vast glacier. The volcano's heat caused the ice to melt, forming lakes in the glacier like liquid bubbles in a partially frozen ice cube. The lakes may have existed long enough for microbial life to have formed there. It's possible that some simple organisms on Earth may be able to survive on Mars today. Methanogens, for example, use hydrogen and carbon dioxide to produce methane, and don't need oxygen, organic nutrients, or light. They're able to survive temperature extremes such as those found during Martian freeze-thaw cycles. So when scientists found methane in Mars' atmosphere in 2004, they questioned whether methanogens already inhabit the subsurface of Mars. As we travel to Mars, though, scientists are concerned that we may contaminate the planet's environment with microorganisms from Earth. That may make it difficult to determine whether life forms found on Mars originated there. The alien life we find may not be intelligent. The Webb telescope and its successors will search for biosignatures in the atmospheres of exoplanets, such as molecular water, oxygen, and carbon dioxide. But even if a biosignature is detected, it won't tell us whether the life on that exoplanet is intelligent or not. Such alien life may be single-celled organisms like amoebas, rather than complex beings that can communicate with us. We are also limited in our search for life by our prejudices and lack of imagination. We assume there must be carbon-based life like us, and that we're the standard by which intelligence is judged. Explaining this failure in creative thought, Caroline Porco of the Space Science Institute says, "Scientists don't go off and think completely wild and crazy things unless they have some evidence that leads them to do that." Other scientists such as Peter Ward, co-author of Rare Earth, Why Complex Life is Uncommon in the Universe, believe that intelligent alien life will be short-lived. Ward assumes that other species will have global warming, too many people, no food, and eventual chaos that destroys their civilizations. He foresees the same for us. NASA predicts alien life will be found within 20 years. In the words of Matt Mountain, director at the Space Telescope Science Institute in Baltimore, imagine the moment when the world wakes up, and the human race realizes that its long loneliness in time and space may be over. It's within our grasp to pull off a discovery that will change the world forever. Using ground and space-based technology, NASA scientists predict that we'll find alien life in the Milky Way galaxy within the next 20 years. Launched in 2009, the Kepler Space Telescope has helped scientists find thousands of exoplanets. Kepler discovers a planet when it crosses in front of a star, causing a small drop in the star's brightness. Based on data from Kepler, NASA scientists believe that in our galaxy alone, 100 million planets may be home to alien life. But it's the upcoming James Webb Space Telescope that will first give us the capability to indirectly detect life on other planets. The Webb telescope searches for gases in a planet's atmosphere that are generated by life. The ultimate goal is to find Earth 2.0, a twin to our own planet,